all know, natural language processing is one of the most used concepts while we are talking about language translation, or if we talk about Alexa, Siri, or Google Assistants. Yes, there are a lot of applications we use every day which are basically used NLP methods. Now, if you are someone who is also working for NLP interview, then this tutorial is for you. In this particular tutorial, we are going to talk about what are the expected questions from the interviewer if you go for NLP interview. So let's get started with the first question for NLP interview. Before we get started, I want to introduce you to Great Learning Academy, a free initiative by Great Learning, where you can access over 200 plus courses with 1000 hours of free content on trending high demand domains such as data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps, management, and many more. That is also for absolutely free. Award-winning academicians and leading industry experts design these courses. You can also get a free certificate of completion when you enroll and complete these free courses. You also get access to the presentation, code, notebook, dataset, and quiz. You have courses in English and Hindi to give you the best learning experience in the language you are comfortable with. Check out the description of this video to access the relevant courses on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out any new update or video release from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video any queries or suggestion, and I will respond to your comments. First question we have, what is NLP? What is NLP stands for and why do we need NLP? Let's have a look at the answer. NLP stands for Natural Language Processing, which is basically used to understand and interpret human language to the machine. Yes, the machine can understand human language by using this particular technique. In short, it is automatic way to manipulate the natural language like speech and text by software for the further analysis to get the required information from them. Right? So this is what NLP stands for. Now let's move forward to the next question. The next question we have mentioned the important components in NLP. So if you already work with NLP, you should know what are the important components you need to know while working with NLP. So let's have a look at the important components we have in NLP. The first component we have that is called the entity extraction. What is entity extraction? Entity extraction is used for extracting information about the entity name or name entity recognition. It helps to identify and classify the key elements from text into predefined categories. Now let's move further to the next one. We have syntactic analysis. But what is syntactic analysis? It is used as a syntax analysis or parsing and the process of analyzing natural language with the rule of a formal grammar. Yes, we have to maintain the grammar rule we have for any language, irrespective of any language basically, right? Then we have semantic analysis. What is semantic analysis? Using syntactic analyzer, it assigns the meaning and also have the linear sequence of words into structures. It helps to define how words are connected and associated with each other. Last but not the least, we have pragmatic analysis. What is pragmatic analysis? It also helps to extract the information from the text. So you can understand what are the components we have talked about. The main thing we need to understand, we need to get the information from a text or a speech. That is what all NLP works for, right? Now let's move further to the third question we have. What are the domains that are currently using NLP? Now, semantic analysis, text classification, Language translation, yes, if you want to change one language to another language, then we use NLP. Then we have word processing, spelling and grammar checkers, right? And last but not the least, text summarization. These are the domains are currently using NLP. Without this also, there are a lot of domains are currently using NLP. As we already said, now it's also one of the most advanced technique to work with the human language. So the next question we have, what is stemming in NLP? Basically, stemming in NLP is one of the most used concepts. So let's have a look at what is stemming in NLP. Stemming is the way to reduce a word. Yes, to its word stem that affixes to suffixes and prefixes. In simple terms, this algorithm works by cutting off the end or the beginning of the word while taking into account a list of common prefixes and suffixes that can be found in an inflected word. Now, let's give an example of that. What is that? Suppose you have a word called cats or you have a word called birds, but your actual word will be cat or bird. Yes, stemming will actually cut those A's and it will give you the actual word cat or bird to get the meaning out of it. Right? So this is how stemming works. Now let's move forward to the next question we have. So then we have lemmatization. What is lemmatization? Lemmatization helps to do the morphological analysis. What is morphological analysis? I will give you the example what is morphological analysis. So basically, if you need to do morphological analysis of the word, you need to go for lemmatization. It is important to have the knowledge about the detailed dictionaries which the algorithm can refer to link the form back to its lemma. Let me give you the example right now. Suppose you have a word of helps or you have word called helping, right? So, the form of the word you have that is different, but the meaning is same, right? So morphological analysis or morphological information will be helps. While we are using helps, the third person singular number present tense help. So your lemma will be help. Now you are using helping. So ing form of the verb you can understand and your word will be help. So basically lemmatization is going to give you the actual root form of your word. Right? Yes. Now, if we talk about what is tokenization in NLP. So basically, tokenization method is used to split a phrase, sentence, paragraph, or the entire text document into smaller units. By doing that, we can get the individual words or terms. Each of the smaller units are called tokens. Right? Yes. When you will start your work with NLP, you have to make your document in a token format, right? And each and every word will be your tokens for NLP, right? Now let's move forward to the next question. So as we have seen, stemming and lemmatization is quite doing same work. So what is the difference between them? Why they have different meaning, right? So let's have a look at the difference between stemming and lemmatization. The topic. First, we need to understand their goal. So stemming is basically reduced inflectional form. Stemming refers to the crude historic process which chops off the end of the word in order to achieve the goal correctly. Right? While lemmatization refers to the do the things properly with the help of a vocabulary and morphological analysis of words. You can understand the main catch over lemmatization is you have to use morphological analysis. Right? Now comes into the implementation. Stemmers are typically easier to implement and run faster compared to lemmatization. And obviously, as it's use a morphological analysis, it takes time and it's also difficult to implement. Right? So let's move forward to the eighth question. What is ENIA? Is one of the most used concepts. But what is that? What is the full form of ENIA? Let's have a look at that. ENIA stands for Name Entity Recognition, which is used to divide a sentence into categories. Now, if I need to give you example, so Google is the most common way to get your answer. Suppose this is the sentence you have. Now you need to use ENIA technique. What ENIA will do for this particular sentence? So your sentence is Google is the most common way to get your answer. We know it's a best source to get your answer, right? Now, as an output, it will give you Google org. So basically, Google is an organization, and this is what you will get by using NER. Yes, so NER basically gives us the entity recognition, the name entity recognition, right? And it's basically divide your sentence into categories. You can see Google comes under the category of organization, right? Yes. So this was pretty much about NER. But where can NER be used? Classifying content for new provider, right? Add more to recommendation systems. We all know recommendation system. Suppose you are going to buy something and this particular company is going to give you good recommendation. So in that case also they use NER. Scanning document for classification, customer supports, chatbots, understanding feedback, and entity identification in molecular biology. Right? So these are the way you can actually use NER. And there are a lot more options are there where NER is using currently. Right? Now, let's have a look at what is feature extraction. Is one of the, again, most used technique in NLP. Feature extraction techniques in natural language processing is used to analyze the similarities between pieces of text. What is actually that mean by, right? And what is the need of feature extraction? Suppose you are using or you are working with the document, and from that document, what you need to do? You have to take the information and the features as well. How actually can you do that? One of the technique is feature extraction, right? And it helps to analyze the similarities between your words, right? Now, what is the need of that? Machine learning techniques cannot work with raw text data directly, and that's where NLP comes into the picture. Feature extraction technique helps to extract the feature from the raw data. You can understand why do we need feature extraction. Now let's move forward to the next question we have. What is the procedure to do feature extraction? Some of the most popular methods to do the feature extractions are bag of words, TF-IDF. Now, let me give you a one liner for what is bag of words or what is TF-IDF. Bag of words is one of the most used methods to transfer tokens into a set of features. And what is TF-IDF? TF-IDF is a statistical measure which helps to evaluate how a relevant word is to document in a collection of documents, right? Yes. So basically, both of the technique is basically giving you a feature extraction from your documents that is needed when we are working with natural language processing. Now let's move forward to the next question. What is latent semantic indexing? I can understand this term is really little confusing. Let me give you an understanding of what is latent semantic indexing. Latent semantic indexing is based on mathematical technique to extract information from the unstructured data. You can totally understand this natural language processing is used to extract information from the human language, from the text, from the documents. So that document on that text can be unstructured. And from those unstructured data, we can easily take or extract the information by using this technique. Now, it was developed to improve the accuracy of the retrieving information, and it has a principle that if a word is used in the same context, that will have the same meaning, right? And identifying the relevant concepts or the components, and also try to group words into classes which represents concepts or semantic fields, right? And last but not the least, it's helped to find the hidden, which is basically latent, relationship between the words, which is semantic. You can totally understand why this technique is called as latent semantic indexing. So latent means hidden and relationship between the words means semantic, right? Let's move further to the next one. What is recall? It's one of the most used question. What do you mean by recall? Proportion of actual positives is identified correctly, which is known as recall. And there is a formula behind it. What is the formula? Recall equals to true positive divided by true positive plus false negative. Right? Yes. Now we will have a look at what is precision. Yes, these are the basic concepts you have to be clear when we go while we are going for NLP interview. So the ratio of positive results which are correctly classified. There is a great formula is there for precision. True positives by divided by true positives plus false positives. Note, precision is the ratio of number of events you can recall to number of all events you can recall. So mix of correct and wrong recalls, right? Yes, there is a relation between recalls and precision when we talk about, right? So let's move further to the next question we have. What are the metrics used to test NLP models? Yes, after you make your model, you have to test your model, but what are the way to test your model? So the first way to test your model, that how NLP models are working, there are few metrics we use. First one is accuracy, that's normal. Then we have precision, we have recall, and F1 score. Yes, we have already talked about recall and precision. We will also talk about what is F1 score. So these are the metrics we use while checking how your NLP models is working. Accuracy is the usual ratio of the prediction to the desired output. We all know we try to get accuracy by checking that what is the actual output and the difference between the predicted output. Right? Let's move further to the next question we have. Now, as we are talking about NLP, to implement natural language processing, you need to have a language. You can use any language, but in this we will provide, or we can actually say that you can use Python. Why Python? And what is Python again? So Python is popular high-level object-oriented and interpreted language. Now you will ask me what are the key points we have under Python for that we have choose Python over any other language. The main reason for Python, it is high-level, object-oriented and interpreted. For a very simple term, let me give you one example that if you know English, how to write a sentence, you are ready to start working with Python. Yes, Python has very less, syntax and very less rules to work on. And it makes your life easy with the lots of libraries it has. Yes, that's why we use Python for natural language processing or any other advanced technique you can talk about, right? Okay, now we will see what are the popular libraries in Python you need to know to start your journey in data science, in NLP, in machine learning, anywhere you want to go for. So in this case, the first library you need to know that is NumPy, which is numerical Python. So if you want to do any type of numerical computation, you have to go for NumPy. Then we have pandas. Pandas is one of the most used case for data manipulation. So maybe you want to make your document in token, or you just want to manipulate your data or load your data. You have to use pandas, one of the most used data manipulation tool you can say as well. Now comes Matplotlib and Seaborn for your data visualization. If you want to visualize your data, then these two are for you. Now, we have NLTK and we have Spacey. NLTK and Spacey are basically for natural language processing. So they have lots of functions which are implemented these concepts we have in NLP, right? So yes, these are the popular libraries we have in Python. Let's move further. What else we have? Useful libraries for NLP in Python. We have talked about two. One is NLTK and Spacey. And we will do a few code snippets as well using this two library, and you will understand this better as well. Right. So what are the other useful libraries we have for NLP? The first one we have NLTK, the Natural Language Toolkit, basically the full form of that. Then Spacey, then we have Jensen, we have Core NLP and PyNLPI. Right. So these are again the most used library for NLP. Again, we do have other libraries as well for NLP in Python. So you can totally understand why we love to use Python, because there are lots of library you will get while talking for NLP or machine learning or data manipulation or anything you want to go for, right? And guys, if you really like the video, do not forget to like and do subscribe Great Learning. You do not get miss any update from Great Learning, right? Now let's move further to the next question we have. Important terms in NLP, right? What are the important terms we have in NLP? Okay. First, tokenization to tokenize your data, then normalization, stemming, limitization, corpus, and stop words. Yes, so we have already talked about stemming, tokenization, limitization. Corpus is a whole data set you have. Stop words, yes, we do have the concepts of stop words, and we will talk about that later. Right? And we also have an important terms in NLP, that is normalization. Right? Now let's look at the last but not the least, that's parts of speech tagging. Yes, which is known as POS tagging. You have to tag your parts of speech for each and every sentence. And we will see how we do that using this NLP, right? Yes, these are the important terms you need to know while starting working with NLP. Now we will talk about what is TF-IDF. We already know why we use TF-IDF. So TF-IDF stands for term frequency and inverse document frequency. This helps to measure the score in order to get the information retrieval, which is IR or summarization. TF-IDF is also used to reflect how relevant a term is in a given document. Procedure to calculate TF-IDF by multiplying two metrics. How many times a word appears in a document and the inverse document frequency of the word across a set of documents. Yes, there are lots of things and lots of ways to do TF-IDF, but you can understand the basic procedure to do that. To calculate TF-IDF, you need to know how many times a word appears in a document and the inverse document frequency of the word across a set of documents. Right? Now let's move further to what is POS tagging. As we have talked about, that is parts of speech tagging. So parts of speech tagging, better known as a POS tagging, refers to the process of identifying specific words in a document and group them as a part of speech based on context. And POS tagging is also known as grammatical tagging since it involves understanding grammatical structures and identifying the respective components. Yes, your NLP should know how to do this POS tagging, right? And the grammar, again, it's very important to work with any language. Now, POS tagging is a complicated process since the same word can be different parts of speech depending on the context. The same generic process used for word mapping is quite effective for POS tagging because of the same reason. Yes, so you can understand what is parts of speech tagging in NLP. Now let's move further to the next question we have. What is the difference between NLP and NLU? Wait, what is NLU? We didn't talk about NLU. Now I will explain you what is NLU, the most common question from an interviewer. So what is the full form of NLP and NLU? For NLP, we know this is natural language processing. But what is NLU? Natural language understanding. What is the origin? NLP is the subset of artificial intelligence. NLU helps to understand the machine, how to interpret and understand the language which are imputed by humans. And what is the goal? NLP focuses largely on converting text to structured data, while NLU, by the help of the NLU, different application can recognize the variation of human language. So these are the basic difference between NLP and NLU. Now let's move further to the next question. What makes NLP difficult for beginners? Yes, if you are a beginner, if you start NLP, maybe you will feel this is really little difficult. But why? There are several factors that makes the process of natural language processing difficult. There are hundreds of natural languages all over the world. Words can be ambiguous in their meaning. Each natural language has a different script and syntax. The meaning of words can change depending on the context. And so the process of NLP can be difficult. If you choose to upskill and continue learning, the process will become easier over time. Yes, this is still a research topic while we talk about NLP. And there are lots of language, lots of way of, expressing your feelings. So being a machine to understand that, it's always a research topic. And if you really start working on that, with time, it will become easier for you as well. Right? Now let's move further to the next question we have. What is Ngram in NLP? Yes, we will talk about what is Ngram because Ngram is one of the most used again part of NLP. N-gram in natural language processing is used to make simple sequence of n number of words. Suppose you have new word. So you can say you have 2 gram. Then you have the golden watch. The golden watch. So you have 3 grams, right? And again, if you have n number of words, it will be n gram. Yes, this is what n gram stands for in NLP. While you do the tokenization, we do use n gram techniques in NLP. Now let's forward to what are stop words in NLP. We know these basic important terms in NLP. So we left with stop words, and now we will talk about what is stop words. Common words that occur in sentence that add weights to the sentence are known as stop words, right? It basically giving weight to your sentence. The stop words acts as a bridge and ensure that the sentence are grammatically correct. In simple terms, words that are filtered out before processing natural language data is known as a stop word, and it is a common pre-processing method, right? So these are the stop words stands for, and you have to work with stop words while you are making your first model with natural language processing, right? Let's further move to the next question we have. So here we are asking about example of real life applications of natural language processing. What are the real life example we actually use every day in our life which are currently using natural language processing? That is really one of the best part of natural language processing. So if we do predictive taste, then email filters, right? And then data analysis, language translation, smart assistants. So when we are talking about smart assistants, we do have Amazon Alexa, Siri, or if we can talk about Google Assistant, right? So all are currently using this particular technique, that is natural language processing. So you can understand basically Amazon, Google, Facebook, all other company are currently using these techniques, right? So you can understand what is the craze for this particular technique, right? Let's go for the next question we have. Now we will talk about what is syntactic analysis in brief. So syntactic analysis is a method to analyze the sentences to extract the meaning out of it. By using this method, a machine can analyze and understand the order of words arranged in a sentence. NLP has the grammar rules of a language which helps in syntactic analysis of the combination and order of words in any documents, like parsing, word segmentation, morphological segmentation, stemming, and linkization. So we have already talked about parts of speech tagging. We do have lots of grammar rules in NLP. Not only in NLP, we do have lots of grammar rules in our own languages as well. Also, we have morphological segmentation, stemming, and lemmatization, right? So yes, these are the things you have to remind when we go for interview for NLP. And if you do like it, do not forget to like the video and do subscribe Great Learning. So we have talked about syntactic analysis. Let's move further. Now we will talk about what is semantic analysis. Semantic analysis can make a machine understand the meaning of a text, and also it uses various algorithms to interpret the words in sentence. It also helps to understand the structure of a sentence. Right, we use semantic analysis for that. So suppose we use semantic analysis for name entity recognition, word sense deambiguation, natural language generation, right? So these are the cases where we use semantic analysis. Now we will have a look at what is NLTK. We know this is a Python library, right? As we have talked before. So NLTK or Natural Language Toolkit is a series of libraries and programs that are used for symbolic and statistical natural language processing. This toolkit contains some of the most powerful libraries that can work on different machine learning techniques to break down and understand human language. So all we need to do on natural language processing to understand human language. A human language can be different type as well. What type we are talking about? Maybe the way you express your feelings, the other person will not express their feelings with the same way. So as a machine, they have to understand the expression, the change of the language using natural language processing technique. It's really interesting to work with, right? So NLTK is used for lemmatization, punctuation, character count, tokenization, and for stemming. So we already have talked about what is lemmatization, what is character count, tokenization, and stemming as well, right? Let's move further what we have. Now we are going to talk about what is unigram. So we have talked about what is n-gram. Now, unigram model is also known as n-gram model or unigram model when the value of n equals to 1. So you can understand the base is n-gram. When your n equals to 1, that time we actually say this is unigram. Now, unigram model is also known as the bag of words model. It helps to estimate the relative likelihood of different phrases is useful in many natural language processing applications, especially those that generate the text as an output. So we have learned about what is unigram. Now we will see what is bigram. You can understand bigram is two consecutive words in a sentence. Now, if we need to give an example of that, the boy is playing cricket. Now, if you see the boy is playing, right? So you can understand the boy is playing cricket. And now if we actually break down this to two, or you can see the bigram method, then the sentence will become the boy is playing, right? So this is how our bigram works. So yes, this is pretty much about this, how bigram works. Okay, we missed one more, that is playing cricket. Okay, let me give you the example one more time. The boy is playing cricket. So if you just break this to a bigram, what will happen? You will get the boy is playing, then playing cricket, right? You can see we have two words at a time, the consecutive two words, which is known as bigram. Now, we will see explain stemming procedure with example. Okay, so in this part, we are going to use Google Colab. And I hope you have all learned about Google Colab. So I personally love to use Google Colab as a IDE for Python. It is basically by Google and this is for AI researchers. If you haven't checked out, you can check out our Google Colab tutorial on Great Learning channel, right? So let's do these things on Google Colab and I will show you how can you start your journey with Google Colab, the basic initial phase. After that, if you feel like you want to learn more about Google Colab, please do not forget to check that in our Great Learning channel and you will get the link in the description below, right? So now we will go to Google Colab and let's have a look at how to do that, right? So go to Google Colab. So I have made my notebook for this particular one. Let me make it a little big for that you can see. But how can you actually reach Google Colab? So go to your favorite browser and just write Google Colab over here. Right? After you write Google Colab, you have to click on the first link. After you click on the first link, what will it give? It will give you new notebook or you want to upload. So for my case, it will be new notebook. So I have just clicked on the new notebook and that's all you have to do. You don't need to install anything. You don't need to install any ID for Google Colab, right? But do not forget to save your work because after 12 hours, your work will be removed from Google. So yes, this is the one thing you have to remind and you have to keep that in your mind when you are working with Google Colab. So right here, you have to, if you can go here, you can see this untitled 69 and here if you just want to change, you can change your, Google Colab file name that is demo.ipyb you can give, right? And this is how you can start working in Google Colab. Now come back to this particular one, which one I was working on. Let me give it NLP interview, right? Okay. So after doing that, you have given your, okay. Yes, you have given your demo book name that is NLP interview. And then I have to install NLTK if my NLTK is not installed. So we are going to do a pip install NLTK. Now, from there, you have to import few things. You have to import NLTK dot first. You have to write NLTK dot stem. Then import porter stemmer. Then you have to write from NLTK dot tokenize import what tokenize. Then you have to call the function called porter stemmer. You can see PST your variable name you have given, that is PST equals to POTUS stemma, right? Now, what do we want to do? What was our question was? So our question was how explain stemming procedure with example. So you can see for the stemming we have already imported from NLTK. Now I have given a list of words. What I have given? I have given like, liking, likely, like, likes. So all the like base or root of the word is like. And from there, we have added few add-ons, suffixes to our words. So here you can see like, liking, likely, like, likes. Now, what we have done, we are going to use a for loop. We have written for I, it will actually go the word one by one. So I will have like, liking, likely, like, and likes. Then it involves, it will go for this particular list. Then I have written print I, the actual word, and then pst dot stem. So after this stemming procedure, I want to see what my actual root word is and what it was, right? So you can see what I have get. I got like to like. Liking is also like. Likely is like. Then like is again like, likes is like, right? So you can understand how this stemming procedure is working with the help of NLTK. And yes, this is how we have implemented stemming using Python. So let's go back to the presentation and let's have a look at and let's proceed with the next question. Right. Now we will see how can you explain unitization. Right. So you can understand again we are going to use NLTK and again we are going to do lemmatization using NLTK. So now again, let's go back to, let's go back to Google Colab and let's do that. Right now, I'm going to write the code and let's see how it's going to work. So here, I'm not going to make any new notebook. In the same notebook, we are going to do the lemmatization as well. So what we need to do, we need to write from NLTK dot stem, right? Now we are going to import word name. Right? The word name part is done. Now we are going to import one more one. NLTK dot stem, right? Import word. Okay, import word mate limitizer. It's already came, right? We have imported wordlet limitizer. So yes. So let's see how can we actually do the limmatization using Python using NLTK. Now we have written from NLTK dot stem import wordnet, right? From there we have written from NLTK dot stem import wordnet limitizer. Now we have called the variable called lemma t equals to wordnet limitizer. We have called this function, right? What we are going to give? We are going to write a list over here right now. We are going to write cats. Then we will have dogs. Then we will give starting basically, right? So we have given a list. We have made a list. Now what we need to do? We are going to do the same thing. We are going to use a for loop. For I in list, then we are going to write print. Okay. We are going to write print I, comma, then this, and then we are going to write what? Lemma t dot lemmatize. And then we are going to give I. Let's see what we will get. Okay. Okay, I am getting an error. And now I have to import NLTK and this. Can you see what error I got? Now, if I do that, what I give, actually I did that because I just want to show you how to import NLTK here and also download NLTK WordNet, right? Let's do that. Can you see it's downloading package WordNet to the root NLTK data? Yes, you need to have this WordNet file with you to do that, right? Now, if I do the same thing, let's see what I will get. Okay. Yes, can you see what I get? I get cats, cat, dogs, dog. But here for starting, I'm getting starting. Let me do C, right? Let's see what I will get for this. For C, I'm getting C. right? Can you see? This C should come C, right? It's not cutting the what? It's not cutting the last ing, the suffix, right? So these are the things you have to understand when it's working fine with lemmatization on where it's working fine with stemming, right? Yes. So let's go back to the representation and let's have a look at what we have in the next. Now we have what are regular expression. Regular expression are used to match and tag words. If A and B are regular expression, then the following are true for them. If E is a regular language, then E is a regular expression for it. If A and B are regular expression, then A plus B also regular expression within the language, and then in the curly bracket A comma B. Now, these are the things you have to remember when we talk about the regular expression. If A and B are regular expression, then the concatenation of A and B, then in the bracket we have A and B is a regular expression again, right? And if A is a regular expression, then A into A occurring multiple times is also a regular expression. So yes, these are the thing, the basic concepts you have to be clear when we go for an interview for natural language processing. Now we will talk about what is dependency parsing in natural language processing. Dependency parsing is a way to analyzing the grammatical structure of a sentence based on the dependencies between the words in a sentence. In this method, various tags represent the relationship between two words in a sentence. Yes, so this is what dependency parsing stands for. Now, if we move forward, we will see what is pragmatic analysis. The pragmatic analysis is one of the important tasks in NLP for interpreting knowledge that is lying outside a given document. The pragmatic analysis focuses on exploring a different aspect of the document or text in a language and which requires a comprehensive knowledge of the real world. The pragmatic analysis allows software application for the critical interpretation of the real world data to know the actual meaning of sentence and words. Yes, this is what pragmatic analysis stands for. Now, if we see where can the NLP be useful, right? So, where actually we can use NLP. So, natural language processing can be useful in communicating with humans in their own language. It helps improve the efficiency of the machine translation and it's useful in emotional analysis too. It can be helpful in sentiment analysis too. It also helps in structuring highly unstructured data. It can be helpful in creating chatbots, text summarization, and virtual assistants. So you can understand from what are the most popular field we have when we talk about natural language processing. Now we will have a look at identify the odd one out. So what we have? We have NLTK, scikit-learn, Spacey, and BERT. So in this case, we will say BERT is the odd one out, right? Because all the ones are mentioned in NLP libraries except BERT, which is a word embedding. Right, we will talk what is BERT in the later, but in this case, you can understand NLTK, scikit-learn, and Spacey all are libraries in Python. Now let's move forward and let's see what else we have. Now, what are the possible features of a text corpus in NLP? Now, we will see what are the possible features we need to have of a text corpus, the document we have in natural language processing. Count of the word in a document, vector notation of the word, sparse speech tagging, and basic dependency grammar. Right? So these are the possible features of a text corpus in NLP. Now let's move forward and we have talked about recall and precision before. Now we will talk about what is F1 score in NLP. Harmonic mean of precision and recall. You can totally understand if one is connected with precision and recall. F1 score will be better option if to seek the balance between precision and recall and the dataset has uneven class distribution. So these are the key point for F1 score. Now if we see the formula for F1 score. F1 score equals to 2 into precision into recall divided by precision plus recall. Right? So now we will look into which of the following techniques can be used for keyword normalization in NLP. The process of converting a keyword into its base form. Right? I will give you an option And from there, we need to get out the actual answer. So, which of the following techniques can be used for keyword normalization? Is it lemmatization, soundex, cosine similarity, and grounds? So, we all know this is lemmatization. Lemmatization helps to get the base form of the word, that is like playing, play, eating, eat, right? Yes, this is how it works. Let's move forward for the next question we have. Okay, so now we are going to talk about which one of the following techniques can be used to compute the distance between two word vectors in NLP. Now I will give you different idea and different option, and from there you have to find it out which one will suits the best. So, which one of the following techniques can be used to compute the distance between two word vectors in NLP? It's lemmatization, Euclidean distance, cosine similarity, and graphs. So our answer will be Euclidean distance and cosine similarity. Distance between two word vectors can be computed using cosine similarity and Euclidean distance. Cosine similarity establishes a cosine angle between the vector of two words. A cosine angle close to each other between two word vectors indicates the word as similar and vice versa. The example cosine angle between two words football and cricket will be closer to 1 as compared to angle between the words football and noodle. Yes, this is how we try to understand the distance between two word vectors in natural language processing. Now we will have a look at what are the possible features of a text corpus in NLP. So let's have a look at the possible features of a text corpus. Count of the word in a document, vector notation of the word, parts of speech tag, basic dependency grammar. So these are the possible features of a text corpus in NLP. Now let's move forward and let's have a look at the other question. I hope you have understood the before questions we have talked so far. You do not have any doubt. If you do have any doubt, do not forget to actually let us know in the comment section. We will love to get back you and try to solve your doubts as well. So the question we have for now, which of the following can be used to reduce the dimension of the data? Okay, the keyword normalization, latent semantic indexing, latent dedicate allocation, right? So these are the three ways to reduce the dimension of the data. Yes, you can understand these three types of normalization, indexing, and allocations we use to reduce our dimension of the data. Now let's move forward. Which of the text parsing techniques can be used for noun phrase detection, verb phrase detection, subject detection, and object detection in NLP? I hope you all know this answer. So now we have first of speech, speedgram and ingram extraction, continuous bag of word, and dependency parsing and constituency parsing. So our answer will be dependency parsing and constituency parsing, right? So it basically help us to do what? To basically text parsing techniques like noun phrase detection, verb phrase detection, subject detection, and object detection in NLP. Yes, now let's move further. We will talk about the dissimilarity between word expressed using cosine similarity will have value significantly higher than 0.5. Is it true or false? Obviously, it is true. The dissimilarity between word expressed using cosine similarity will have value significantly higher than 0.5. Do not forget that. Now we will have a look at which of the following is keyword normalization technique in NLP. Stemmings, parts of speech, name entity recognition, lemmatization, right? So you can understand our lemmatization is a keyword normalization technique in natural language processing. Now let's have a look at in NLP, the algorithm decreases the weight of commonly used words and increases the weight of words that are not used very much in a collection of documents. So term frequency, TF, inverse document frequency, what to weight, latent definite allocation, which is nothing but LDA. So you can understand what to weight, decrease the weight for commonly used words and increase the weight for words that are not used very much in a collection of documents. Right? Now let's go further. In NLP, the process of removing words like and, is, and the from a sentence is called as what? In lemmatization, all the stop words such as a, and the, etc. are removed, right? So this a and the are nothing but your stop words. One can also define custom stop words for removal. So if you feel some of the words has become a stop words for your particular document, you can customly add them as well. Right? Now let's move further. The process of converting a sentence or a paragraph into tokens is referred to as stemming. True or false? The statement describes this process of tokenization and not stemming. Hence, it is false. Yes. So basically, just to break this, the whole documents into token, it's nothing but known as tokenization, not as stemming. Now let's move further and let's have a look at our 51st question, what we have. Tokens are converted into numbers before given to any neural network. True or false? In NLP, all words are converted into a number before feeding to a neural network. So yes, this is right that we actually do converted our numbers like our tokens into number before giving it to neural network. So you can understand by it, every words are converted into number before you can actually go forward these things to a neural network. Let's move further and let's have a look at what else we have. Now we are going to talk about again identify the odd one out. So you have an ticket, scikit-learn, spacey, bird. So again, your answer will be bird, right? Because this is not a library. Now we will talk about TF-IDF helps you to establish what? So TF-IDF helps you to establish how important a particular word in the context of document corpus. TF-IDF takes into account the number of times the word appears in the document and offset by the number of document that appears in the corpus. Right? So you can understand why we use TF-IDF. Right? Then TF is the frequency of term divided by a total number of terms in the document. Then TF-IDF is obtained by dividing the total number of documents by the number of documents containing the term and then taking the logarithm of that quotient. So you can understand how TF-IDF works. Now, last but not the least, TF-IDF is then the multiplication of two values TF and IDFs. Right? Yes, this is how TF-IDF help us to establish this. Now we will talk about the process of identifying people and organization from a given sentence paragraph is called what? Semi, lemmatization, stop word removal, name entity recognition. So we have talked about what is name entity recognition, in short, which is known as NER. So the process of identifying people and organization from a given sentence is nothing but known as name entity recognition. Now let's move further. Which one of the following is not a pre-processing technique in NLP? It's stemming and lemmatization, converting to lowercase, removing punctuation, removal of stop words. Which one is not a pre-processing technique in NLP or sentiment analysis? We know stemming and lemmatization to remove suffixes, converting to lowercase the part of processing. Removing punctuation, yes, again the part of processing, data pre-processing. Then the removal of stop words, we need to do that. So again, it's a pre-processing. So all of them is a part of pre-processing technique, but sentiment analysis, it's not a part of pre-processing technique. Converting text into tokens and then converting them into an integer or floating point vectors can be done using count vectorizer. Count vectorizer helps to do the above, while others are not applicable, right? So you can understand why do we need to use count vectorizer. Now let's move forward. What's represented as vector are called as neural word embedding. True or false? What do you think? So true. What to make glue-based models build word embedding vectors that are multi-dimensional, right? Yes. So word represented as vectors are called as a neural word embedding, right? Yes. Now let's go further. Context modeling is supported with which one of the following word embedding? What to wait? Clove, bird, all of the above. So we know it's bird. Why? Only bird, the bidirectional encoder representation from transformer support context modeling where the previous and the next sentence context is taken into consideration. In what to wait? Clove only word embedding are considered and previous and next sentence context is not considered. So you can understand the difference between bird and what to wake and glove. Right? So mostly in the past days, we used to use what to wake and glove. As we see, NLP is a research topic. There are every single time they try to come up with a new research or a new way or technique to understand the language. So now this bird is one of them, the advanced topic, which actually takes into account the previous and the next sentence context, whereas what to wait and clove cannot take that into consideration. Right? So you can understand the topic. Now we will see bidirectional context is supported by which of the following embedding? What to wait, clove, but what? So obviously again it's bird. So the answer will be again for only bird provides a bidirectional context. The bird model uses the previous and the next sentence to arrive at the context. What to wait and glove are what embedding they do not provide any context. Right? Let's go further. Which word embedding can be custom trained for a specific subject in NLP? Then bird. Obviously, that bird word embedding can be custom trained for a specific subject in NLP. So again, your answer will be same. That bird is a bidirectional encoder representation from transformer supports context modeling where the previous and the next sentence context is taken into consideration. This is the basic thing you have to understand while we are talking about bird, what to wait and glove, the basic difference between them. That bird takes into account the previous and the next sentence context. Right? In what to wake and glove, only word embedding are considered and previous and next sentence context is not considered. Right? Let's move further. Word embedding capture multiple dimensions of data are represented as vectors. Right? It's true or false. It's obviously true. So word embedding vectors help establish distance between two tokens. True or false? It's true. One can use cosine similarity to establish distance between two vectors represented through word embedding. Now, let's further to the next question. Transformer architecture was first introduced with OpenAI's GPT. Yes, the transformer architecture was first introduced with OpenAI's GPT, and ULM Feed has an LSTM-based language modeling architecture. This got replaced into transformer architecture with OpenAI's GPT. Right? Now, let's have a look at which of the following architecture can be trained faster and needs less amount of training data. Yes, data is the one of the most important thing when we talk about natural language processing or neural networks or artificial intelligence. So LSTM based language modeling, no, it takes data. It needs data. It's not that faster. But transformer architecture, yes, were supported from GPT onwards and were faster to train and needed less amount of data for training too. Right? So this is the privileges you will get if you use transformer architecture. Now let's go and let's see. Same word can have multiple word embedding possible with EMLO. Word embedding supports same word with multiple embedding. This helps in using the same word in a different context and thus captures the context than just meaning of the word, unlike in globe and what to wait. NLTK is not a word embedding, right? Yes, EMLO word embedding supports same word with multiple embedding, right? Now let's move further. For a given token, its input representation in the sum of embedding from the token, segment, and position embedding. So ELMO, GPT, BART, ULM fit. So obviously it's BART, right? And BERT uses token, segment, and position embedding for your reference. Now we will see trains two independent LSTM language model left to right and right to left and shallowly concatenates them. Right? So GPT, BART, ULM lift, ULM feed, ELMO. So you can understand again it will be ELMO. Now ELMO tries to train two independent LSTM language model left to right and right to left and concatenates the result to produce word embedding. You can understand this is one of the most advanced technique to do that. Now we will see uses unidirectional language model for producing word embedding. So GPT uses unidirectional language model for producing word embedding. GPT is a bidirectional model and word embedding are produced by training on informational flow from left to right. ELMO is a bidirectional but shallow obviously, and what to make provides simple word embedding. Right? Now we will see the relationship between all words in a sentence is model irrespective of their position. Which architecture is this? OpenAI GPT's ELMO, BART or ULM feed. So again it will be BART. Now, I want the list of 5 use cases to be solved using NLP techniques. Sentiment analysis, obviously, language translation, English to German, Chinese to English, etc. Document summarization, question answering, sentence completion, right, sentence completion. So these are the 5 use cases to solve using NLP techniques. Yes, this 5 are not that. There are lots of other applications also we have which are this problem use NLP techniques. Now let's move further. Transformer model pays attention to the most important one in the sentence. True or false? True. Attention mechanism in the transformer model are used to model the relationship between all words and also provide weights to the most important. Right? Now we will see which NLP model gives the best accuracy amongst the following. Excellent, right? Excellent has given the best accuracy amongst the all methods or all the models. It has outperformed BERT on 20 tasks and achieved states of art result on 18 tasks, including sentiment analysis, question answering, natural language inference, etc. So you can understand, ExcelNet is again one of the most advanced topic to work with. Then we will see permutation language model is a feature of ExcelNet. Obviously, this permutation you can understand again it's a advanced topic we use in ExcelNet, and ExcelNet provides permutation based language modeling and is a key difference from BERT. Right? You can understand the difference between ExcelNet and BERT. So ExcelNet use permutation based language. In permutation language modeling, tokens are predicted in a random manner, not sequential. The order of prediction is not necessarily left to right and can be right to left. So the original order of the word is not changed, but the prediction can be random. The conceptual difference between BERT and ExcelNet can be seen from the following diagram. Right? Yes. So for that, if you want to check it out, you can check the difference between ExcelNet and the BERT. So you can understand ExcelNet is one of the most used model right now these days. Now we will see Transformer Excel uses relative positional embedding, true or false. So obviously it's true. Instead of embedding having to represent the absolute position of the word, Transformer Excel uses an embedding to encode the relative distance between the words. This embedding is used to compute the attention score between any two words that could be separated by n words before or after. Right? Let's move further to the next. This is one of the most asked question. What is naive Bayes algorithm? Naive Bayes classifier are belonging from simple probabilistic classifier based on Bayes theorem. So you can understand PA given B equals to PB given A and probability of A divided by probability of B. Like you can say probability of B given A equals to probability of B being true given that A is true. Probability of A obviously, and probability of B equals to probability of B being true. Right? Yes, this is pretty much about what is need bias. But yes, interviewer do ask what is need bias and how it's different from Bayes theorem as well. Now, if we move further, we need to look into when can we use need bias algorithm in natural language processing. So, need bias works better with natural language processing problems. Need bias is a part of probabilistic algorithms which give the advantages of probability theory and Bayes theorem to predict the tag of the text like a piece of news or a customer review. Now we will talk about explain dependency parsing in NLP. So dependency parsing, also known as syntactic parsing in NLP. You can understand the one of the other name of dependency parsing is syntactic parsing. So it's a process of assigning syntactic structure to a sentence and identifying its dependency pairs. This process is crucial to understand the correlations between the head words in the syntactic structure. The process of dependency parsing can be a little complex considering how any sentence can have more than one dependency pairs. Multiple trees are known as ambiguities. Dependency parsing needs to resolve these ambiguities in order to effectively assign a syntactic structure to a sentence. Now, last but not the least, dependency parsing can be used in semantic analysis of a sentence apart from the syntactic structuring. Right? Now, let's move forward to the next question we have. What is text summarization? I've heard this term for so many times when we talk about this interview questions. So, let's have a look at what is text summarization. So, text summarization is the process of shortening a long piece of text with its meaning and effect intact. Text summarization intends to create a summary of any given piece of text and outlines the main points of the document. This technique has improved in recent times and is capable of summarizing volumes of text successfully. Yes, this is what stands for text summarization. Extraction based summarization and also abstraction based summarization. These are the types of text summarization we have. Now we will talk about what is NLTK. So we have used NLTK so many times. For your reference, for the one more repeat time, what is NLTK? NLTK or Natural Language Toolkit is a series of libraries and programs that are used for symbolic and statistical language, statistical natural language processing. This toolkit contains some of the most powerful libraries that can work on different ML techniques to break down and understand human language. NLTK is used for lemmatization, punctuation, character count, tokenization, and stemming. Now we will talk about how is NLTK different from species. We know one more library that is used mostly with NLP, that is species, how they are different. While NLTK has a collection of programs to choose from, species contains only the base suited algorithm for a problem in its toolkit. NLTK supports a wider range of language compared to species, and species supports only 7 languages. While Spacey has an object-oriented library, NLTK has a string processing library. Spacey can support word vectors while NLTK cannot. So yes, these are the difference between NLTK and Spacey. Now, if we talk about what is information extraction. So, information extraction is a context of natural language processing refers to the technique of extracting structured information automatically from unstructured sources to ascribe describe the meaning to it. This can conclude extracting information regarding attributes of entities, relationship between different entities, and more. Now we will talk about what is pragmatic ambiguity in NLP, right? So what is that? Pragmatic ambiguity refers to those words which have more than one meaning and their use in any sentence can depend entirely on the context. Pragmatic ambiguity can result in multiple interpretations of the same sentence more often than not. We can come across sentences which have words with multiple meanings, making the sentence open to interpretation. This multiple interpretation causes ambiguity and is known as pragmatic ambiguity in NLP. Now, we will talk about what is masked language model. So basically, masked language model helps learner to understand deep representation in downstream tasks by taking an account from the corrupt input, right? This model is often used to predict the words to be used in a sentence. Yes, this is what masked language model stands for. Now we will talk about what the base NLP tools you know. Some of the base NLP tools from open sources are Spacey, Blob, Textacy, Natural Language Toolkit, Retext, NLP.js, Stanford NLP, and CogComp NLP. Right? So these are the base NLP tools we know. Now, if we jump forward in the next question, what are the main challenges of NLP? Breaking sentence into tokens, parts of speech tagging, understanding the context, linking components of a created vocabulary, extracting semantic meaning are currently some of the main challenges of NLP. Yes, these are the things you have to deal with if you start working in natural language processing. Now we will talk about which NLP models gives the best accuracy. Net Bayes algorithm has the highest accuracy when it comes to NLP models. It gives up to 73% correct predictions, right? So you can understand still NLP is a part of a research, topic. So we always try to make new model and new way to make our NLP model best. Now we will talk about what are the major tasks of NLP. Translation, name entity recognition, relationship extraction, sentiment analysis, speech recognition, and topic segmentations are few of the major tasks of NLP. Under unstructured data, there can be a lot of untapped information that can help an organization grow. Now we will see what are the stop words in NLP. Common words that occur in sentence that add weight to the sentence are known as stop words. The stop words act as a bridge and ensure that sentences are grammatically correct. In simple terms, words that are filtered out before processing. Natural language data is known as a stop word, and it is a common pre-processing method. Now we will see how to prepare for an NLP interview, the most important question we all want to know. The best way to prepare for an NLP interview is to clear about the basic topics. Go through blogs that will help you to cover all the key aspects and remember the important topics. And also do not do not forget to check out this video. I hope this will have lots of questions and that will basically you can expect in your interview time. And learn specifically for the interviews and be confident while answering all the questions. Right? So whatever you have learned, be confident about that. Now we will talk about how to write a code in Spacey to check word similarity. For this, again, we will go back to Google Colab and I will show you how can you do the word similarity. So you can see that this is what we are going to do in Google Colab. We talked about what is Google Colab. And again, if you do not check out our video on Google Colab tutorial, please do check that. You will get the link in the description below. Right? So let's have a look at what is how can you do this word similarity using Spacey. For that, you have to import Spacey and you have to download en4WebSM. Right? So you can see the same way I have done. Now I have loaded this part. Right? Now I'll say print enter two comma separated words. So you will give two different words with the comma. Right? Now, how can you take a user input? In order to take the user input, you have to write input and you have to call this function input. Then I have bring those data to the tokens and then we will do something. So here you will get okay. Now I'm going to write help and helping. Right? Or maybe I can write apple and orange. Let's have a look at what is the similarity I will take for them. Right? Now you can see what we have. Now we are going to write for loop and there we are going to write for I in tokens print I dot text, I dot hash vector, I dot vector norm and I dot is underscore OOB. Let's have a look at what are those. Text, the word string has vector if it contains, right, if it's already contained, a vector representation in the model. Vector norm is basically the algebraic norm of the vector. And is underscore OOB if the word is out of vocabulary. Right? So now if I do this, let's have a look at what I will get. Okay, can you see the apple? True, true, true. And orange, true, true, true. Right? So yes, there is a similarity between apple and orange. And this is how we can do the word similarity in spacey. Now let's go back to the presentation and let's have a look at the next question we have. Now we have a question for how to implement lemmatization using NLTK. Right? Again, let's go back to the Google Colab and let's have a look at how can we do that. So we have done this lemmatization before as well. If I am not wrong, yes, we have done this. What we have done, we have actually imported nltk.stem import wordmate. Then we have imported wordmate lematizer. Then we have wordmate, like we have called wordmate lemmatization function to actually lemmatize your word. Now you have done this, you have downloaded WordMate. Now you have a list of cats, dogs, and scene. And maybe here I can do laughing, right? Okay. Now, in this case, what I have written lemmatize. So basically, do the lemmatization. So here you can see cat is cat, dog's dog, and laughing is also laughing. It's not able to do this laughing part. So yes, this is how we can actually implement lemmatization using NLTK. Now let's look into the next question we have. Now there is a question that implements parts of speech tagging using NLTK. How to do that? How can you actually do the parts of speech tagging using NLTK? For that, again, we are going to do this in Google Colab and I will show you in practical how can you do this parts of speech tagging. Now we will do this particular part. How can we do the POS tagging using NLTK? For that, we have to import NLTK. NLTK.download, then stop words. You have to download stop words from NLTK library. Then you have to write import NLTK from NLTK.corpus import stop words. Now from NLTK.tokenize import word tokenizer dot send tokenize. So you have to tokenize your data as well. So for stop word, what we have written stop word equals to say stop words dot words that will be in English, which language it is. Now we are going to import NLTK and download count and import again in Acha. You don't need to do that. You can just do this. And we have also downloaded average perceptron tagger, right? And then we have written tokenize. Maybe you can write tokenize or same tokenize. Welcome to Great Learning YouTube channel. Now I want to see parts of speech tagging for Great Learning for this particular sentence, which is welcome to Great Learning YouTube channel. Now I have written for I in tokenizer, right? I am going to write I in tokenizer. What list equals to NLTK dot what tokenize, that is I, right? Okay, I just need to write tokenizer. Let me do that. Okay, for I in tokenizer, then what tokenizer used to find the words and punctuation in the string. You can see word list NLTK dot what tokenize Y. Then what list W for then write I or J for J in what list if not J in stop word, right? Then you have write tag NLTK POS tag words list print tagged. Let's see. Okay, I get done. Small. Okay. Did I change anything? Tokenizer. Okay. Right. Okay. Let me do that. Okay. Can you see what I get? I get this parts of speech tagging. Can you see? For welcome, Great Learning YouTube channel. Right? Can you see what I get? I get this parts of speech tagging for each and every word I have in my sentence. Right? Maybe you can change it and you can check how this is going to work. Yes, this is how we can do parts of speech tagging using NLTK. Now let's go back to the presentation and let's have a look at the last few questions we are left with. So now we will have a look at implement Enya using spacey. Again, you have to implement Enya using spacey, but how to do that? Right? So basically here we can do NLP equals to spacey.load the way we did encode the web essay. And from there, you need to write a text. Maybe we have written a text. Google is the most common way to get your answer. And then you have to NLP text means you have to tokenize them. And from there, if you write document.ents, basically ents.text and ents.star character and in character and ent.label. That time it will give you Google as an organization. Google org. So you will get Google is the organization you have in your data. And this is how we do in NER using Spacey. Now, NER stands for name entity recognition. We know it is used as entity chunking or extraction and the most popular technique in information extraction to identify and segment the name entities. It helps to classify or categorize the entity under various predefined classes. Now let's move further. What is BART algorithm? I said we will talk about that. So BART is a bidirectional encoder representation from transformers. It's a pre-trained model developed by Google to natural language problems. Pre-trained model by Google to solve more complex NLP problems with total trainable parameters of 110 million. Right? And it has a deep bidirectional representation in the architecture, helps a machine to understand the meaning of words in a sentence with all the nuisance of context. Right? Yes, this is what BART stands for. And it is used the concepts of the transformer in the BART algorithm. Right? So let's go back to the next one. What is sequence model? Yes, they are needed when we start working with the deep neural net, not the neural, when you work with the natural language processing in a deep or in a very precise way, you have to know what is sequence model. In sequence model, past observations are used in the same sequence to get future prediction. So we have two types in sequence model. One is directed model, one is undirected model. What are these in under directed model? Bayesian network, Markov model, hidden Markov model, RNN, LSTM. And under undirected model, we have conditional random field. Alright, now let's move further and let's have a look at what is Markov model. A random process with Markov property to model the randomly changing system. Future states only depends on the present state. This is what Markov property is. Does not have memory. States or the inputs are observable in a Markov model, used in predictive modeling and weather forecasting. Right, now we will have a look at what is Markov chain, a sequential random process that helps to transition from one state to another within an allowed set of states. A simple Markov model is known as the Markov chain. A Markov chain is a discrete state space process where the future state only depends on the present state, known as discrete time Markov chain. Discrete time Markov chain equals to sequence of random variables, which is x1, x2, x3 with Markov property. So what is that? The probability of x n plus 1 equals to x given x1 equals to x1 and x2 equals to x2 dot dot till xn equals to xn. Yes, this is what Markov property stands for. Right? Okay. Now we will talk about what is hidden Markov model. Hidden Markov model is an invisible Markov chain and its states generates the random visible output. Simplest, memoryless, dynamic Bayesian network and prediction based on the present state are not directly visible and output depends on the states. This is what hidden Markov model stands for. And HMM is fully connected. The main catchy point over here that hidden Markov model, in short known as HMM, is a fully connected model. Now we will look into types of feature extraction in NER. So simplify POS tagging, lowercase word, uppercase words, splits each words, find out the titles, find out nearby features of each word. This is how the types we have to do the feature extraction in name entity recognition. Now we will talk about what is undirected model. Undirected graphical model is an alternative representation for joint distribution. No interaction between A and C, node and B and D. Conditional independence of A given C when B or D is given. B is independent of D given A or C. Right? This is what undirected model stands for. Now if we talk about what is conditional random field, an undirected graphical model to find pattern recognition in structured prediction. And CRF is an undirected discriminative probabilistic graphical model. No natural condition between the nodes. Conditional probabilities are placed by affinity or factor when the neighbor node is known. And it is a cyclic in nature. Right? So we almost came to the end of this particular tutorial of natural language processing interview questions. We hope you like it, and do not forget to subscribe Great Learning, and if you really like this video, do not forget to like it. Thank you so much, and please, I think this video is going to help you. Thank you so much. Thank you. I want to introduce you to Great Learning Academy, a free initiative by Great Learning, where you can access over 200 plus courses with 1000 hours of free content on trending high demand domains such as data science, machine learning, artificial intelligence, programming, cloud computing, digital marketing, DevOps, management, and many more. That is also for absolutely free. Award-winning academicians and leading industry experts design these courses. You can also get a free certificate of completion when you enroll and complete these free courses. You also get access to the presentation, code, notebook, dataset, and quiz. You have courses in English and Hindi to give you the best learning experience in the language you are comfortable with. Check out the description of this video to access the relevant courses on Great Learning Academy. So what are you waiting for? Register now and start your learning journey today. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out any new update or video release from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video any queries or suggestion, and I will respond to your comments.